Hello, my name is Michael Glinsky, CEO of BNZ Energy Incorporated, speaking to you from beautiful Santa Fe, New Mexico. You can actually see behind me some of the trails where I ride my mountain bike. And I would like to go and speak to you about a new economic theory that is at the cornerstone of the construction of BNZ Energy. With no further ado, let me bring up the presentation and start the presentation. This is a new unified economic theory. What I mean by this is that there's going to be a unification of the monetary, that is, how the money supply is determined and controlled, with the fiscal investment policy, or how investments are gone and made in the economy. Traditionally, the monetary policy has been governed by monetarism that has been uncoordinated with the fiscal policy. And that in monetarism, that you have a central bank that is controlling the money supply via a central discount or prime rate that the central bank loans out money at. This is an autocratic capitalistic, that means profit or resistivity or interest-based monetary policy and control. Also, traditionally, things have been handled from the fiscal investment side with the concepts of Keynesianism. That's where you borrow and spend in order to be able to make the investment by the central government. And since you're borrowing it, there is a interest rate associated with the borrowing or the issuing of something like T-bills or by the US government, or gilts by the British government. This is an autocratic, okay, there's a central government, capitalistic, that means it's profit-based with this interest, fiscal policy and control. And especially from the firm's perspective, that the optimization is made in terms of profit. But these two things end up being uncoordinated. Then this is now then also there is a separate macroeconomic, or the way that the overall economy is controlled based off of the fundamental equation of monetary policy, which is that the gross domestic product, or GDP, is equal to the money supply, M, times the velocity of money, V. And then from the microeconomic or the firm perspective is that you have a maximization of discounted cash flow, or DCF, underneath the constraint that the net present value of the opportunity needs to be greater than zero. And what we're going to be doing is bringing the two together. In fact, examining the firm like an economic commune of that firm and its suppliers and suppliers. So you have more of a microeconomic commune. And so that we're going to approach the overall economic system as a multi-scale web, or mathematically, it's a graph of economic collectives, so that we'll have the distributed constrained optimization at each one of the nodes of this multi-scale web, each one of the corner points of it, where you will go and maximize MSR, where M is the economic multiplier, S is a savings multiplier or temporal multiplier, and M again is a network multiplier. And R is the primary revenue of that firm or the economy. And that the overall and you can see that on the right as the time integrated revenue multiplied by this network multiplier, multiplied by the savings or temporal multiplier, and then divided by the payback time for the investment. That is, again, you can now go and identify that the GDP is going to be equal to the network multiplier times the revenue, which is also equal to the money supply divided by the savings rate. Since the savings rate is 1 over the velocity of the money supply, this is equal to MV. So you can see now that we have the fundamental equation of monetary policy really represented here. And so not only are we going to go and have each one of these economies or these firms maximizing its MSR, this is also equivalent to a revenue maximization or a GDP maximization of that sub-economy, or also a maximization of the money supply. And here there will be a different currency associated with each one of the nodes in this graph or this economic web. So there's not going to be not only one central currency, but there will be individual currencies associated or transactional equities associated with each one of the nodes in the graph of this web of economic communes. One thing to also note is that this theory now, since everything is going to be revenue maximizing, and that the interest or the friction is going to be removed from these economies, that we're going to release this web of economic collectives from the tyranny, the economic tyranny of this viscosity. And that, so what we're really going to be having is what you end up seeing here on the left, which is a overall entities that are distributed entities that are maximizing this MSR or being revenue maximizing entities underneath a constraint that an investment needs to be less than the amount of sustainable economic activity that's going to be created by this investment. This is also equivalent to saying that you will only do things that will increase the value of the currency, that is, have no inflation of the currency. Well, in fact, you will always see that the currency will be increasing in buying power as time goes on. And that this will be in contrast from what is done now when you end up using resistive control of the economy, that you go and you will see that these entities will be DCF maximizing firms under the constraint that the investment needs to be less than the discounted cash flow. That is, that the net present value needs to be greater than 0 for the entity. And what we're going to be going and replacing it with, since we're removing this resistive control, is going to be replacing that with generative artificial intelligence, genAI, forecasting and control for the economic entities. That's both macroeconomic and microeconomic, because you have to remember now, though, we're going to treat everything like a macroeconomic entity. This has really large implications, as you see here in this bottom box, in terms of both the performance of the economy and the scale of the investments that can be made in the economy. Because discounted cash flow is equal to MSR times 3 different factors. The first factor is the profit margin. The second factor is a factor that goes and favors quick projects, with respect to very quick payback in an exponential factor in the numerator, and also short lifetime projects in the denominator. Then also that you'll see that it's also reduced because the DC by this 1 over the economic or network multiplier times the temporal or savings multiplier, because the DCF does not go and give you credit for the economic knock-on and temporal knock-on effects associated with it. So the DCF is much less than this money supply or this GDP factor or revenue factor. And it's not just a little bit. I mean this in a big way. At least a factor of 10, if not a factor of 1,000 less. And we do see this because if you go, and I have examples of where that if you now go and operate the business according to a revenue maximization, that you will go and see that the business will perform 10 times better. Okay. And also you can go and see, for instance, currently with respect to the energy transition, that we are only going and investing right now tens of billions of dollars, which is really a nominal amount compared to the $20 trillion that is estimated to need to be currently invested per year in the energy transition. And this is obviously a factor of 1,000, as I've indicated here. And now I want to go and take a step back. And since we are going and are basing everything on this constrained optimization of the time integrated revenue, which is a functional, right? It's an integral of that quantity. It's not simply an optimization of a function. Then I want to go and talk a little bit about the mathematical methods of constrained functional mathematics of optimization. This is the core mathematics of economics and also of physics. If you go and pick up the book by Chang on the fundamental mathematics of economics, you will go and see that he lays out these three methods that I'm about ready to discuss. And also, this is true of physics, that if you would go and pick up a book on classical mechanics by Goldstein, you would see that there is also developed the three approaches that I'm going to go and talk about now. So that the basic problem is going and optimizing one of these functionals, which for us is the time integrated revenue of this economic commune. That if you're going and resistively controlling it, you end up going and adding in this red factor that you can see, this exponential factor, this discount factor, that is now associated with the resistivity, this artificial viscosity that you're adding by the control system through the central bank and also the borrow spend funding or financing, borrow loan financing that is artificially introduced into the systems. This is subject to a constraint, which is the force equation on it, right? And that now if you go and is the physics of the interaction, the way that economic entities interact, right? And that this can be approached from three different perspectives. The first is the Lagrangian approach, which is using the method of constrained optimization, utilizing Lagrange multipliers, where you go and you define a Lagrangian function, as is shown here, where L naught is a function of the f of q, q dot, and R is obviously the reward function. And you can now go by principle of least action, where the action is the integral of the Lagrangian along the path or the evolution, and that you can end up therefore with the Connell equations being Lagrange's equations. Um, and that is a second order differential equation in the two quantities. That more of the mathematical structure can be exposed if you go and make a Legendre transformation or a change in coordinates from q dot to p, and to be able to get to the Hamiltonian perspective. And I do want to go and make it, and that normally in the economics literature, Q is referred to as the state of the economic system, and P is referred to as the co-state of the economic system. And when you go and make this Legendre transformation, you now go and get a definition of the Hamiltonian of the system, capital H, which is equal to this PF plus RQ, and where P can be identified as the partial of the Lagrangian with respect to Q dot. And that the Lagrange equations now has gone and been transformed into uh, the Hamilton's equations, which are two first order differential equations involving the Hamiltonian, which you now go and solve for Q and P. And that also, there are many other very interesting things that can be gone and shown. For instance, that the volume is conserved underneath the flow in PQ, or conjugate variable or phase space, as it's called. And also things can be gone and referred back to constants of the motion or symmetries of the motion. But this goes and really goes and gives probably the most insightful way of taking a look at um, uh, this motion, which is in terms of the generator of the canonical transformation, or a generator that generates the motion. This particular, what we will now go and look in terms of the action or the integral of the Lagrangian, which will now go and give that's is equal to the action, or which I'll go and talk about a little bit more in a second, and the energy, E sub P of the motion. And that you go and then can show that you can solve a differential equation for the action that generates the motion, that's called the Hamilton-Jacobi equation. And also you can see in red here the additional term that you have to add if you're going to go and add viscosity to the system. That again, I want to go and say that this action S sub P, which is the integral of P sub Q along the path of motion, is also equal to the negative of the entropy that you will go and find the path that minimizes the action or maximizes the entropy. This is also referred to in deep reinforcement learning, a method of artificial or generative artificial intelligence, as the approximate value function, where in this case it is the value created along the perspective or the economic value. And the approximation parameter is actually this capital P, and then is the state of the system. Also, for generative pre-trained transformers, you're probably more familiar with this acronym GPT with respect to Chat GPT, which uses these generative pre-trained transformers, and is the approximate distribution or score function or approximate log likelihood, where now the approximation parameter theta takes the place of the capital P, and the little x is the state or coordinate little q. This also is called Hamilton's characteristic function in classical dynamics, but it is the generating function of the canonical transformation. And you can look at this as the action that generates the flow, and that this ends up being approximated by generative artificial intelligence. Because in most circumstances that the original Lagranges of the equations are the equations that are normally easiest to be able to solve directly. Where this generator, even though it is very conceptually valuable to think of it as the generator of this canonical flow, governed by Hamilton's equations, and also directly determined by the Hamilton-Jacobi equation, that the Hamilton-Jacobi equation is very difficult to be able to solve directly and get a closed form solution, but it is extremely easy to go and approximate with generative AI, and especially AI that are piecewise linear universal function approximators, because that these motions are also geodesic motion or maximally flat motion that is very easy for a piecewise linear, maximally flat approximator with certain that has certain discontinuities or singularities in it that can be fit via the cusp in the piecewise linear approximation. And now let me move on to the fact that in terms of these collectives, that we do not have just one entity and looking at its overall motion, that we end up having a collective of these interacting entities, right? These economic entities that are interacting. For physics, it's going from one atom up to many different atoms that could interact, or one elementary particle to many particles that could interact. In the first case, that's called a plasma. In the second case, it is called a fluid or a field of these particles. And that now you have to go and take a look that we are actually presented with the ensemble or a group of all of the particles that are going and interacting here. And that what we're going and seeing is the reflection of the master individual, or I call the puppet master of that. And then we go and we see that this puppet master or this individual that's undergoing this simple motion that we've gone and just discussed, this that can be generated via the solution to the Hamilton-Jacobi equation, and is again following this nice geodesic motion here, that he goes and gets multiply reflected, right, back up onto, or multiply scattered up onto this community or this economic collective that we end up having. And you can view it as he's being viewed through a hall of mirrors of where he has gone and been reflected multiple times. And that now, in order to go and discover what is happening here, that the motion in the collective needs to be multiply descattered, okay, or deconvolved, or deeply deconvolved with this what we will call the Heisenberg scattering transformation, or as a generating functional, okay, in this case. And so that we can go and uncover this very simple motion in a very few dimensions, rather than this infinite dimensional image that we have here, a few coordinates, right? And then if we go and study this in the few coordinates, we will want to decode this into these fundamental capital Q and capital P variables, so that we can go and be able to find, and which will tell us what these geodesics are of the motion. And that, so you'll see that the puppet master will move around these geodesic motions, and external forces will push them in a direction that is gone, and or external economic forces and actors will push it in a direction that is perpendicular, or in this capital P direction. Okay. And also, that the very last thing I'd like to point out is that if you know what these singularities are, which here it says branch point beta through here, that you can solve Laplace's equation and know what all of these geodesics are, so that all of the information is gone and determined in terms of these beta stars, or these overall singularities of the surface, or the boundary of the surface. And that tells you everything that you need to know about these surfaces. And now let's take a closer look at the mathematical form of each one of these transformations. First of all, this generating functional, or this deep deconvolution from this, going backward through this hall of mirrors to go and expose this puppet master, or the Wizard of Oz that is controlling everything, ends up being a iteration of going and first of all taking this logarithm of things. Then you go and you apply this sort of pooling operator that goes and gives you the first order look at how things are done, or in this case, just the way that people are just sort of distributed around, or correlated around the image. Then we go, or the averaged value of it. Then we go and convolve it with this bank of filters. We go and take another sort of collection, or this activation function of it. Then we go and we apply this pooling operator, and we get the way that in this case, the individuals will be correlated, okay, around there, okay? Then you go and do this again and again and again to go and to show you the way that individuals are correlated into families, the way families are associated with their small commune, the way then that communes are correlated into villages, the way villages are correlated into cities, the way that cities are correlated into states, the way that states are correlated into countries, and finally, the way that countries are correlated into the world economy. Now, if we go to the next point, which is this decoding into the capital P and Q, or the generator of the motion of the in this individual puppet master, that or this which is this SP of Q, that this is what we go and we directly use these piecewise linear universal function approximators are, along with a particular structure that are called multi-layer perceptrons or MLPs, in order to go and to find out the way that these things are correlated around, or the way there's effectively a geodesic finder associated with it, right? And it's very interesting to note, though, that this decoder or this generating function is also equivalent. When you find it, you end up going and finding what the other one is that I just talked about, or the generating functional. Even though here it appears as two steps, as something different, but it turns out that the generating functional is just the functional equivalent of the generating function. Okay, now let me go and show an example of a physical system. This physical system is an electron that is here, that is moving about an orbit around an ion in a strong magnetic field. And that there are two different types of this motion. One is where the electron goes around a little tight cyclotron orbit and then slowly drifts around the field, and as it goes and bounces back and forth and then drifts around it. These are things that are called guiding center atoms. There's another one where they both go around their cyclotron orbits and then drift perpendicular to the magnetic field. These are called drifting pairs. On the right-hand side, you can go and see the motion of two different guiding center atoms that come close to one of these sticking points, or these beta star, or these singularity points. You can see that even though they are very separated by just a little bit, they end up going and traveling around at different speeds. And in fact, you'll see the faster of these two, which is the blue, end up lapping the orange one. And also do note that as you get close to this sticking point, that they slow down. And for an orbit that goes and arrives at this sticking point, you'll see that it takes an infinite amount of time in order to approach that sticking point. And now let's go back a bit and take a look at the different orbits here and how the phase space is laid out. We were tracking one of the guiding center atoms that was going close to the sticking point X that is shown here. And that you also see that these drifting pairs go and are shown in this area that is shown over here. And that the also that there are three areas that are now divided by what's called this separatrix because it separates them, shown by the dark black line. And that separates the area of the drifting pair motion from the guiding center motion. And that also there's a third motion here, which is the free motion, Dobby's free, where that you can go and move around that, okay? And that you really want to go, and there are also and external forces will go and act in a direction that is perpendicular to the motion, and will also always go and try, the thermal force will always try to rob you of energy or take you to one of these orbits that has less energy. Okay. And but if you now go and see that there are these X points that you end up here can be looked upon as points of economic prosperity, okay? Or they are also topologically mountain passes or local minimums or are stable equilibriums or are metastable states, since it takes an infinite amount of time in order to get to them. But there are also these areas of sort of local minimums, but are stable, or these O points. And these are either points of economic recession, where there is some chronic unemployment and the economy is not behaving and is not optimally uh, operating at full employment with much higher levels of GDP, which you would have at the X points. But there are also these points that go to negative infinity, which are these points of economic depression or economic black holes, where you see that you get total economic collapse. And let's say that we go and are operating here and start here and are going around one of this orbits that is a pretty good orbit with a good amount of economic activity. What you see is that external entities will take out motion so that you will now go and spiral around and eventually sort of go back and forth in the vicinity of the recession by the amount that the external the entities tend to bounce you back and forth, okay? And what we really go and want to do is, instead of going down as shown on this middle picture, of going down into one of these valleys of economic recession, we really want to go and somehow take the path up here to the mountain pass of this economic prosperity or this nirvana. And that, in terms of Keynesian economics, it's like, how can you borrow and spend and stimulate the economy to get up to this point, right? Or how can you control the economy to get up to this point, right? And that let's sort of go and talk about this and say that we're initially here, running around here and bouncing back and forth in this area, around this area of economic depression. Well, let's say that you would borrow and spend to get up to this orbit, and you would go and take a long time to go back up to this point where would, the sticky texture or this point of economic prosperity. But eventually you would move away from it, interact with external demons that would go and spiral you back here, just so that you'd have to be re-stimulated again. This is a Sisyphusian task. The government would have to borrow more and more to do this. And so that the principles of economic conservatism are to just sort of don't worry about this, just go, and hopefully you're at one of these points of depressions that aren't too bad, and just go and exist at that point, okay? Because that also, if you would tend to overstimulate the economy, you would go over here and let's say that, and you would eventually move close to the separatrix that would take you into this area of economic depression. And then if there would be a market crash, if there'd be some type of pump and dump done in order to move you into this area, you will then go and spiral down into this point of total economic collapse, like was seen in the United States, in the subsequent to the pump and dump in October of 1929 and the subsequent economic collapse of the 1930s. And so this goes and shows that you really would like to go and have something that would go and keep you around this X point. And the way that this can be done, I would propose, is by this method of Ponderomotive stabilization, or creating a little alpine valley at this mountain pass nirvana. And let's go and watch this video and listen to it to go and understand the way that this can be done.
Position. This equilibrium point is stable because if we perturb it, the pendulum will slowly return to the equilibrium point. The upper vertical position is another equilibrium point, but it is unstable because any small perturbation will make it fall to the lower equilibrium point.
The upper
And
point
now let's
is
power the
ended up
jigsaw
being
to
what
see
we
what
call
happens.
the X point, and the lower point is the A point. Okay, isn't that cool? Really though, and the way I like to think about this, right, is that this is really it's like I go and when I want to go and control my dogs, that I go and they have a buzzer on. When they do something that I like and they're behaving properly, I do nothing. When they go and they do something I don't like, I buzz them. When they do something I really don't like, I buzz them really hard, okay? And then when they do something I really don't like, I go and I give them a small shock. And that the way that you can think about this then is that it creates a ponderomotive potential so that they want to go and circulate around that little alpine valley. And this is really what is also done by sheepdogs, that they run around real quickly and they effectively buzz the herd to make them go and create this force because they don't like being buzzed. And so they go in the direction of least buzzing. And that's what happens here. And this is done because at the point of equilibrium, that you end up having what is effectively infinite mass. You're an immovable object, so that the force has no force on you. But as you move away from it, that your mass gets less so that you can be moved more. And so that there's this automatic potential that is put on you associated with these particular points that you wish to stabilize. And so now let me get to these overall sort of methods of the collective control. That, that what happened in the United States because of the civil rights movements of the 60s, that a lot of the resistivity in our society was removed. So that when Jimmy Carter came to try to control that, became president in 1976, that he really had no way to control it. He sort of looked at it, it went out of control and had very large resulting inflation. Well, the reaction to this opening up of society, starting in 1971 with a manifesto that Lewis Powell, who eventually became a Supreme Court justice in the United States, was a way of re-exerting friction on society and locking up society, which is coming to its natural conclusion with the rise of fascism or autocracy in the United States. And what we're proposing is that because of this transactional equity or money associated with each one of these economic communities and artificial intelligence control, creating the sheepdog of the value of the economy, we're at a dawn of a new era of sustainable economic prosperity in this Alpine Valley that's shepherded by artificial intelligence. And also, these images were also made by Dolly, the of OpenAI, artificial intelligence. But now I want to go and talk a little bit about the interaction of the objective function that's optimized, whether or not that is DCF or GDP, and or in the method of control, whether or not that's generative AI or resistive AI along this axis, which is really whether or not it's a socialist or a Ubuntu or a commune way of controlling it, or it's capitalistic or it's profit maximizing, versus socialism, which is revenue maximizing. And on the other one is the distribution of the control, whether or not that's a web of economic communes or is a single economic commune or is centrally controlled by a centralized government, a centralized bank, a central committee, okay? And I call that either autocracy versus democracy, whether or not you end up having monopolies, both market and political, or free markets associated with things, right? And so that there is now a matrix of countries or associated with what these are, okay? There are, first of all, the autocratic socialisms of countries like the USSR, China, Cuba, and North Korea. There are also the democratic socialist countries like the Scandinavian countries, to a lesser extent, France, Portugal, Australia, Canada, Switzerland, Germany. And also, it's very interesting that most of the indigenous cultures of Africa, the Americas, and Australia, And there are then the unstable democratic capitalist countries like the United States of the 1960s, initially Israel, Hungary, Turkey, and Russia underneath Gorbachev and Yeltsin. And then finally, these capitalist autocracies, uh, countries like Hitler's Third Reich, Putin's Russia, Trump's United States, Erdogan's Turkey, Orban's Hungary, Netanyahu's vision for Israel, and really over most of history, most of Western civilization. One thing to note is that the autocratic capitalist autocracies are stable. They have poor performance. That the socialist autocracies are also unstable, mostly because they have very poor performance historically. Also, though, that the capitalist democracies are also unstable with reasonable or modest performance, and that the best ones of all that are stable are the socialist democracies. And now going through these again, that democratic socialism is stable with high performance. They are also rated the happiest countries in the world. This was also successfully deployed in the American West from 1830 to 1860. It was developed using multiple paper currencies. This was led by the Wells Fargo Bank, founded in 1852, where each bank, which covered sort of one day's horse ride, had its own note, promissory note, or currency that it could print. During this time, there was a 2 times decrease in prices due to increased productivity or deflation, and a 100x increase in GDP of the American West. To this date, a good example of one of these economic cooperatives is the REI Co-op for recreational equivalent. It is 90 years old and going. It's the premier U.S. retailer of camping gear. It currently has $4 billion per year in revenue and 15,000 extremely happy employees. That this leads to a distribution of wealth, power, and control to customize the guidance that is sharing, leading to and reinforcing a free market democracy. This is in contrast to autocratic capitalism uh, that is stable with poor performance, or an autocratic socialism with is unstable with very poor performance. And the one that also that we've taken a look at a lot, which is democratic capitalism, which is the one that's very familiar to most economics departments and business schools. This is the capitalism, monetarism of Milton Friedman and the University of Chicago School. You can note that firms underneath this method of control have very short lifetimes, an average of about 15 years and shrinking. The diffusive model, because the diffusive model does not capture disruptions, does not model them, and the force of profit prevents transition through market disruptions or market transitions. So the old firms like Sears fail and are replaced by new firms like Amazon. And also this resistivity of about 6.7%, kind of an average sort of prime AAA sort of interest rate, constrains and grinds the business to a halt because of this resistivity in about 15 years. That's 1 over the interest rate. So that the imposition of the interest or the dissipation says that the business is going to gives you a economic forecasting that the business will go to zero in 15 years. And the business, because of the imposition of that friction, does go to zero in 15 years. So the imposition of the interest rate, the interest, the dissipation of the economy is a self-fulfilling prophecy. You will go and see a concentration, a natural concentration of a force concentrating the wealth, power, and guidance, so that you will have monopolies and autocracies, that is greed, that will go and have an irresistible force almost despite everything you try, any regulation or any democratic constitutional constraints, that you'll see that somehow they will be vetoed and that you'll end up with monopolies and autocracies despite your best effort. And so now go and really altruism versus greed, sharing versus greed. First of all, it is better to share than be greedy. We're taught this as young kids. Share your toys. Share your toys by putting them in a community toy chest so that each individual child will have more toys to choose from and therefore be happy. The community software chest is GitHub. The community capital chest was first implemented by Martin Luther as his community chest of the Protestant Reformation, rather than the chest of indulgences of the Medicis that they implemented as they first had their bank and then became popes. The modern version of this, which is proposed by this theory, is the electronic transaction equity version of this capital chest, is Ubuntu or print grant financing. This is a sharing business model where you have sustainable revenue maximizing. You'll see that it has a business cycle, which is 2 to 6 years of savings of inventory, both input and output, as well as cash in terms of the transactional equity. It is forecast using genAI models and also controlled using that. The Ubuntu uses Ubuntu print grant financing. The stakeholders, that is the employees, the suppliers, the customers, are the stockholders, owners of the transactional equity. It is socially responsible, that it respects the dignity of the employees, suppliers, and customers. This is in contrast to today's greedy model, where none of the children will share. It is short-term profit maximizing. It only has a transactional cycle or 15 days-ish, or uses just-in-time inventory of savings and inventory. Is forecast using a diffusive model, that is this discounted cash flow analysis, or the Black-Scholes equations, which is the diffusion equation for options and derivative securities pricing, or uses an exponential diffusive model. You use debt financing, that you see that the stockholders of the firms are not the stakeholders of the economies of the firm. You go and see that society is exploited that is there's when I say society, I mean the employees, the suppliers, the customers of the firm, and also a kind of subtle point is that also intellectual property is also monopolized and exploited and is not allowed to be shared so that it can have the maximum effect on the goodness and the daily life of society. Okay, let's talk about the consequences of greed. And I'm going to become a bit philosophical here. As you see here by Mr. Greed himself, a pile of money, right, that Mr. Greed has is not entitled to homage or periodic indulgence. That is additional money being added to his pile by the adoring people who just come up and want to add money to his pile, right? The equivalent is that a vendor is also not entitled to multiples of what they have invested or will invest in a good or service in compensation for that good or service. Generative artificial intelligence is about better forecasting and control of the collective systems, leading to better decisions and ultimately social, including economic good. That is, we're talking about enlightenment, not entitlement, right? And also another way of looking at this is that this crazy motorcycle rider over here on the right-hand side, right? And that he's using resistive control, right? Indulgence or usury leads to resistive control, like going full gas on this motorcycle, then braking to control the speed. It is effective control but wasteful of energy and leads to much less performance, right? For an economic collective, this effectively stabilizes and controls the economic collective, right? But constrains the economic collective from reaching the maximum level of sustainable economic activity and robs it of revenue needed for sustenance and growth, right? So it both goes and is always constrains you because you always have to be giving this extra energy away and operating in that way, and also robs you of what's needed for the eventual sustenance and growth. And so that you may most of the time will see that these economies will be operating at 1/10 or less of the level that they should, and that their growth ends up being, if they need to be in a growth mode, like a developing economy or the whole world now with respect to the energy transition, that the growth can be literally 1,000 times less than it should be if you are trying to go and control things like this motorcycle on this rather hair-raising ride. And now finally, for the conclusions, that we're talking about a new unified economic theory that is stable democratic socialism, which relaxes the capitalistic diffusive approximation made for control so that there is now a coordinated yet distributed monetary and fiscal policy made to maximize GDP, not DCF. It replaces the viscous forecasting and control with generative artificial intelligence for the forecasting and control. It replaces autocratic capitalism, which has uncoordinated, viscosity-based, centralized monetarism for monetary policy and Keynesianism for fiscal policy. We are moving from this dystopia of autocratic capitalism with this new unified economic theory to the utopia of democratic socialism. I'd like to thank everyone for the time that they've taken to listen to this. And again, thank you, and hopefully that you've learned something new.